Please mute all. Maybe video started preaching. Can stop your video. I mistakenly might got started. Another 1 minute will wait and start. I started sharing screen. Okay. We'll start so other peoples will automatically join. So thank you all for taking out the time on Saturday. And so this is about the COMSTACK. Basically, I'll brief about the COMSTACK, this AUTOSAR basics, and then I'll start with the COM. So previously also I have given one same free demo session for diagnostics also in the last month. So similarly, I am giving this one on the COMSTACK. So I hope screen is visible. Just can unmute and please confirm. Okay, thank you. So I'll just brief about myself. Mostly the details are available on the LinkedIn also, but just to highlight, I have 11 plus years of experience into embedded C and AUTOSAR. So specifically into AUTOSAR, I have more than 7 plus years of experience. I have done mostly all the model configurations, mostly all the stacks like uh, whatever present. Like we have a COMSTACK, we have a memory stacks and other things also. Apart from that, I have did MCAL integration also to configure Watchdog Manager or maybe FE, FLS, then SPI, I2C, all the models actually. Then we have a diagnostics, then we have a XCP. So XCP is generally used for calibration purpose. So that XCP configurations also I have done. Then NVM strategies like we have a NVM minimum write capacity and we have a minimum read capacities also. So how we can tackle those problems so that our EC will live long, maybe 10 years, 15 years. So how to protect the multiple rights, all those things also I have done with the multiple OEMs like BMW, Porsche, and other. So that's all about myself. So we'll just brief like why AUTOSAR, why not other things, why not conventional software? Because if you see like in a normal scenario, if you want to do a single change of a variable also, we have to follow all the layer by layer architecture. We have to do the configuration. We have to invest so much time, okay, to do a single line change or maybe a single variable addition or maybe a single addition of any pin. We have to do a lengthy process, okay. So why we are still doing the AUTOSAR and why all OEMs are preferring the AUTOSAR? So this is the questions comes because most of the peoples who are started 10 years back or maybe 6 7 years back, so they must be having the experience of our non-AUTOSAR projects. So their things are very easy. Like you want to just add let's say one new sensor, you just configure as a GPIO in one line. and just make it as a output in one line, or maybe input as a one line, and then that's all. So it's easy. But why we have adopted AUTOSAR is like, day by day, few manufacturers are there that are having a limited things, like some controllers are maybe not that much capable, or some controllers are not having that much capacity. So when we have started today, we don't know, like after 5 years or 6 years or 10 years, what will happen to that microcontroller, or maybe what will happen to that particular manufacturer. So we never know, like there might be chance that that manufacturer will become a bankrupt. I request you all to just mute all, so that will not get noises. So we never know, like after 5 years or 10 years, what will happen to those manufacturers. Okay, so what will happen? Let's say now we have done a project, and it is working everything correctly, but after 10 years, that company stopped manufacturing that particular controller. So then what will happen? After 10 years, we have to do the same changes again. We have to modify the things again. We also not sure, like the engineers that are there 10 years back are still there in that organization or not. So these are the major blockers, these are the major problems. So let's say, so due to this, what happened, like all the big players, like big organizations, like a Robert Bosch, BMW, and all the big players come together, and they how to tackle the problem. For that, they started this AUTOSAR thing. So what actually AUTOSAR is like, it's a basically a layered architecture where we are making our software which is independent of the hardware. So hardware means you can it can be any microcontroller, no issue, but your application will be still there. You just have to replace the relevant hardware files, or maybe you can consider as a mcal files that manufacturer will provide, and your project will run smoothly. So you need not to do rework again and again. So let's say right now you are working with a ST microcontroller. After 10-20 years, some microcontroller has been stopped. So you can migrate to Infineon microcontroller, or maybe RX microcontroller, or maybe your Renesas microcontroller as well. So every microcontroller organizations are giving you a SIP, or you can consider it as a MCAL packages, and accordingly easily you can just replace the mcal, and your all project will work. Some minor changes obviously you have to do, that are not big, but your application will remain same. So you need not to modify a single line of your application. Only the driver layer level changes only you need to do, that are also minor, and that relevant organization will support to migrate from one controller to another controller. So to resolve all those stuff, this AUTOSAR come into picture. So just a briefing of, like we have a hardware independent application functions. So whatever may be the application software components, or whatever may be the applications that you have, it becomes the hardware independent. And some standardized stacks also we have, that we directly configure. Only the few changes on the mcal side only we have to do. So that's why in long run, where you are right now, 10 years back, or maybe if you want to go ahead for 20 years later also, it will not be any trouble. So our project will live long, and even if something happens, it will not impact the things actually. So that's why AUTOSAR come into picture, and everyone is following. Even if you want to do a single line change also, it will be common. And everyone knows, like if something you are communicating, something you are doing, it is as per the AUTOSAR standard. So there will be a less chance of issue in the hardware also, and in the software also. So this is a layered architecture, where we have application layer, we have a RT, we have a service layer, we have a ECU abstraction layer, and we have a complex driver, we have a microcontroller. So these are the layers actually. So in the application layer, we will be having our application software components only. And 1 minute. So 73 people are joined. Good. So another thing will be, like in the application, we will be having our application software components. Application software components means our normal APIs, or normal our code, handwritten code, where we will develop our logic, our implementation, and everything which is relevant to your core application or maybe a core company level. So or maybe a proprietary level. So every organization will be having a different set of coding standard, so they will follow, and that will be a part of your application layer. So then we have RT. RT is nothing but it's just a mediator. That mediator means it just get the data from the application, send it to the below layer. Also, it will get data from the below layer and it will send back data to the application layer. So whatever communication you want to do, either it can be a BSW level communication, application level communication, or maybe a complex driver level related communication. Each and every communication has to go with the RT only. There is no way that you will directly communicate, application will directly communicate with the BSW layers or maybe a complex driver layer. So each and every communication has to be go with the RT only, that is the AUTOSAR runtime environment. So that's why it is highlighted, and it will, the line also you can see it is started from this to this. So next will be our service layer. Service layer means it is like a OS. We can have a OS, we can have our CAN NM, CAN SM, like that way. We have a DCM, DEM. So these all modules will come into the service layer. So I'm just briefing because I want to dive into the COMSTACK. Just to highlight on the short, I'm briefing. Then we have ECU abstraction layer. Then we have microcontroller abstraction layer, and then microcontroller. And this is complex driver. Complex driver means what? The things which are not done with the AUTOSAR standard, and the things which are very time critical, because you see, you want to if you want to write a single variable value also, it has to go from application, then RT, from RT it has to go to service, from service to ECU abstraction, then MCAL, and then microcontroller. So for every layer we have a functions, and for every functions we will be having some periodicity, we will be having some time decays. So if you want to run a safety critical applications, if you want to run a motor control applications, or which are very high frequency in nature, let's say you want to run a motor. So to run the motor, you want to run the PWM. To run the PWM, you must have a like a 20 kilohertz frequency or maybe more than that. So to run such things, it cannot be done with this particular flow. So there will be always delay. So to avoid that, we, the motor driver related applications, or the some like airbag related operations, generally we do with the complex driver only. So what will happen? The application software component will directly communicate with the complex driver with the help of RT. So it will bypass service layer, ECU abstraction layer, and microcontroller abstraction layer, and it will directly communicate with the microcontroller. So that's why where the complex driver come into picture. Though it will follow the application layer and the RT layer, but it will directly communicate with the hardware with the help of complex driver. So to reduce the time and to reduce the delay, that's all. So that is about the layered architecture. So this is just a dive deep, like what exactly ECU abstraction layer consists of, what exactly your what we can say below layer consists of. So just I have given a depic. So this is also part of your AUTOSAR standard document only. So you see, like we have a memory services, we have communication services. In the communication services, COMSTACK will come. In memory services, we will be having NVM. Then you have system services. In the system services, we will be having DET, DLT. We will be having OS to manage everything. Then here you have a IO hardware abstraction layer to manage the input outputs, to manage the pins, GPIO pins. Then we have a complex driver. Then in the memory hardware abstraction layer, we will be having your P module to manage the NVM. In the communication hardware abstraction layer, we will be having a PDR and other modules. In the this onboard device abstraction, we will be having the TPs and all things. In the memory driver, we will be having FLS for flash driver. Then we will be having a CAN interface or Ethernet interface or link interface based on the communication stack that you have configured. Uh, and we have IO hardware drivers also, like we have a PWM, GPIO, all those stuff will be there. So this is about your generalized things on the AUTOSAR side. So now we will dive deep into the COMSTACK. What exactly the COMSTACK? What is the role of it? how the com stack will play a role, and why we term it as it's a heart of our AUTOSAR. Because without communication with the external world, our EC will be idle only. So to send data to the outer world, to receive data from the outer world, communication is a mandatory. So how this communication will happen, how application software communicates with the com stack, how it communicates with the below layer, what all things it has to be done, what all features it provides. So that I will try to cover in this session. So these all things will be present in our standard document also, but some things I have written from my side also, which will be a practical approach of how COMSTACK will work and what all features it has. So things like you see, first feature is like it will provide the signal oriented data interface. So signal oriented data interface means like we can have a signal. Signals means you can consider a variable. Okay, so let's say engine RPM, we have a engine speed, we have a engine temperature, we can have a some data like current voltage, then whatever things, okay, whatever variable values, so you want to send to the other component, or you want to use that component values to the diagnostics, whatever may be the things, okay, so that comes under a signal. So for example, you want to get the airbag status or door, what is the door status, or what is the ultrasonic values, sensors values, all those things are considered as a values or variables, and every variable will be considered as signals. So signal is nothing but a simple variable in normal terminology or normal embedded C. So it will it will create interfaces for signals. So whenever you want to send any value to the below layer, or maybe any value you want to send via Ethernet or CAN or LIN or FlexRay, whatever may be the model you want to communicate with, so you have to create one signal. So after if you create a signal, then further things will be done, like it will create a RT ports and all those stuff, it will create automatically. So first thing will be the signal. Then packing of AUTOSAR signals to the I-PDU to be transmitted. So every signal is not go alone. So each signal has to travel with the I-PDU only. I-PDU is nothing but it's just a protocol data unit that has to go below layers via PDUR. So every signal will be used there, and signal can be individual signal also, or can be a signal group also. So let's say you want to do the powertrain related signal, so you can group the all signals together, and we term the name as a power signal. This one, powertrain. Or if you want to read the ECU parameter, so you can create a signal group as a ECU parameters, or let's say some diagnostics parameters, or some Ethernet parameters. So we can create a groups also. So but lowest element of the com stack is a signal. So signal is the lowest element. So from signal only other things will be created, like a signal group we can create. We can create I-PDU groups, we can create I-PDU, all the stuff will be done, but lowest group, lowest element of the com stack will be the signal only. Then packing of signals, so we can pack the signals together, and we will form a I-PDU, and that we can transmit with the below layers. Unpacking of the received I-PDUs. So you see, like signals cannot travel alone, because signal is a application level term. So application software component will create a signal. That signals will go to the RT. From RT, it will go to the COM. So similarly, while receiving also, first it will receive to the COM, and then after receiving the I-PDU, because I-PDU can consist of like 2 signals or 10 signals or whatever may be, with the, based on our configuration. So how we can unpack it? So how we can unpack it? So that unpacking will be handled by the COM itself. So then we have a routing of the signals from received I-PDUs into the I-PDUs to become a transmitted. Sometimes what happen, we will have a reception from one level, one layer, and we have to send back to the another communication layer. For example, you want to receive data from the CAN interface. Let's say you want to read the status of the door, and let's say you want to send the data to the Ethernet. So you are receiving the signal from the door control module via CAN, and you want to send the received data to the Ethernet to show it on our, let's say, dashboard or display, whether door is open or not. For example, generally on a car you can see that it will show the icon like a door I open or door close, like that way. So how that communication will be? So that internal routing also, if you want to do that routing also, we can do with the help of COM itself. So it will, we will receive it from the we will receive it from the CAN, and if you want to route it to the Ethernet, that also we can do. So that we will term is as a PDU routing, PDU gatewing also we can do. Then we have a communication transfer transmission control, like whether you want to start or stop some particular I-PDU groups. So let's say right now your vehicle is stopped, or maybe you are in a development stage. So there obviously you are not connected your car. So you can stop the engine parameters or ECU parameter PDU, because even if you start, you will not get anything because car is not connected to the ECU. So it will avoid the bus and it will avoid the collision also. So you can start, you can do the transmission stop of certain PDU groups or I-PDU groups, that or we can stop also. So that also feature will be provided with the by the COM itself. Then replications of send request, you can replicate the send request, we have internal APIs that you can use, and you can send the request manually also. We can trigger the request internally also. So you need not to have everything connected to your ECU. So you can simulate the things also. Then we have a guaranteed minimum distance between the transmit I-PDUs. So it means that whenever you are sending data to the below layers, so it will be having a minimum distance between the two PDU, or maybe a minimum delay between the two I-PDUs. So it will be not like I'm sending the data now, it will be sent in the microseconds or maybe in nanosecond, because my controller can work on the microseconds or even nanoseconds also based on the clock we provide. So it will also provide you the distance. Okay, it will also provide you the minimum distance that it will be automatically handled by the COM itself, so that there will not be any loss of data, or there will not be a big traffic on the communication, maybe whatever communication medium you are using, either Ethernet or LAN or whatever maybe. So based on that, it will also try to try to do the things, like it will allow the minimum delay also. So we have reached now 88 participants. Thank you all for support and taking out the time. Then next will be it will monitor the received signals. So how monitor receive signals means, like, let's say your vehicle is running, and you are getting the vehicle speed, for example, whatever the current speed vehicle is running at, let's say 10, 20, 30, 40, 50, whatever may be. So it is expected that at a certain periodicity, maybe 100 millisecond, 200 millisecond, or maybe 10 millisecond, 20 millisecond, whatever may be the periodicity, you are expecting that I should receive the speed, so that I can show it on our dashboard. So you see, whenever you are running the car, uh, if it is a like an analog value, the needle will move here and there. If it is a digital display of your speedometer, it will increment the value like a 20, 30, 40, right? So how it will increment? So to increment, obviously ECU has to receive the speed data from the engine control unit, and then after that only the value will be modified and it will be shown on your display. So to do that, you must get the timely data from the engine control unit. So that is of monitoring the received signal. So if you are not getting the speed data continuously at a rate that you are decided, then there will be a error, or there will be a timeout come. So that timeout handling also done by the COMSTACK. So it will just trigger a warning or maybe a DTC. Obviously, it will not be shown to us, but as a developer or as a the one who develops the project, they will get the notification that yes, we are not getting a particular signal. So timeout handling also done by the COMSTACK. It will trigger a event, or maybe it will trigger a error based on our configuration, or it will trigger a DTC also based on our configuration. Then filter mechanism of incoming signal. So there might be chance that the ECU that you are connected can be connected to the many of the ECUs, like a 10, 20, 30, 50 ECUs. So which signals has to be filtered? So that obviously filtering done at the below layer only, on the CAN driver layer only. But there might be chance that some signals we are not required at all, though they it is a part of our CAN message or a part of Ethernet message, but those messages we don't want to consider, though it will come to the PDUR level, but I don't want to pass to the above applications, like because COM is a one, we will receive the data from the PDUR, but whether that whatever data which you received from the PDUR, that you want to pass to the above layer or not, okay, like application layer or not, that will be handled by the filter mechanism. So if you are handling some data filter mechanism, like a change on change, or maybe you are getting repeated same data, then it's of no use to send data to the above layer, or else above layer will be busy. So to have a less traffic on the thing, or maybe less CPU load, or to reduce the load of the processing, we have a filter mechanism of incoming signals also. So that feature also provided by the COM itself. Then we have a different notification mechanism. Notification mechanism is like it will give us a COM will give us a notification when some signal is available, or some signal come, or maybe some group signal come, or some PD will come. We will be having a notification. So the notification can be a RT call, or maybe a COM callback also. So sometimes based on our configuration, we will call RT call. So let's say you want to process the data. So how you will calculate the speed when you get the data from the below layer? So it's not a good idea to directly calculate continuously infinitely. So what we will do, we will create a RT call for the notification. So whenever we will get the speed of the vehicle via below layer, then only you have to do some calculation and show it on the dashboard, or show it on the instrument cluster. So for that we will have a notification. So we will create RT call underscore whatever name, like let's say received vehicle speed, and based on that only we will try to call the relevant application, so that multiple call of application will be avoided and there will be less CPU load. So that notification handling mechanism also done by the COM only. Then we have a provision of init values and update indications. Like what example, whenever you are using a signal, or maybe whatever signal groups, whatever maybe things, because signal is the lowest element, so you have to provide some init values. So if you don't provide init value, it will not run. So let's say you have mode, like whether you are in a development mode, whether you are in the field mode, or maybe in the engineering mode. So you have one, let's say, variable to detect what is the state of the issue, like whether it is a test mode, engineering mode, or develop mode, or field mode. So based on that, what will happen, it will try to behave, EC will try to behave. Let's say you are in the test mode, so whatever request you send, EC will accept. But let's say you are in the field mode. So in field mode, what happen, field mode means like the car is given to the customer, so it is a field mode. So EC will not accept any request. So then we have a like a technician mode. So whenever you are your car is going to the service center, let's say you are let's say some issue is come, then you are going to the service center. So then the authorized service center have a set of request and set of tools. So they will enable the technician mode. So then the technician will be having certain set of things. So we must have some init values for each signal. So that init value thing definition also done in the COMSTACK itself. So by default, we will be having in the developer mode. So what we will give, we will give some 1 or 2 or 3, whatever the enum value that we want to give to that signal. So whenever we compile the code, by default, it will be in the development mode. Whenever we are in production, let's say car production is ongoing, we have released the software, everything is ongoing. Whenever we are in the production mode, then what will happen, we will set that value default as a 3 value or 4 value, whatever may be because I'm just giving the example that enum value will be obviously a company specific. So that thing also managed by the COM itself. Then byte order conversion. Byte order conversion means like whether the our ECU is a little Indian or maybe a big Indian. There might be chance that our ECU is a little Indian, but the ECU that we are communicating with is a big Indian. So that byte order conversion also taken care by the COMSTACK. So while configuring, you have to decide the signal that I'm sending or the signal that I'm receiving from the outer world is of which Indianness. It's a little Indian or big Indian. While sending, we can select like it's a little Indian. Let's say some data we are receiving from the other controller that is a big Indian. So you can configure that. Accordingly, COM will handle the Indianness. Automatically it will be handled and you need not to worry of it. So automatically it will be handled on the COM layer itself and we will directly get the real data. So that's how the COM work. Then sign extension. Sign extension means like let's say assume that we are getting a ADC value. So obviously you all aware like some ADC is of a 10 bit, some ADC will be of a 12 bit, right? But we don't have any variable of a 10 bit or we don't have any variable of a 12 bit. So what will happen whenever we are getting a 10-bit data of ADC or maybe 12-bit data of ADC? So automatically COM will do the sign extension. So whatever happen when we get a 10-bit or 12-bit, it will automatically extend it to the 16-bit. So like that way, sign extension also will be taken care by the COM only. Then it will support the transmission modes like we have to do the trigger transmit or transmit on change or receive on change. All those stuff will be handled by the COM. Then signal based gateway. So as I told you earlier also, we will be having signal as a lowest element. So the signal can be a 1 bit also. Signal can be 2 bit or 1 byte also. So it can be a 1 bit also. Okay. So while sending the data, let's say we want to send a 4-bit signal to the other component, software component. We can send that also because we will create a runnable, we will create everything and accordingly it will communicate also. So we can do the signal based gateway also. So we need not to send a complete CAN message. Let's say you want to communicate with the within software components like we have two software component A, software component B. Software B component B wants to read the what is the status of the ECU. So as we have created signal, so it will be routed by RT and the other signal will read it RT underscore read and it will get the real data. So it need not to send a complete signal group also because signal group is a group of signal. A signal group can have a 10, 20 or more than 20 signals also. But while sending, we can send a unique signal also, or we can send a group signal also. While receiving also, we can read a particular signal also, or we can read a particular signal groups also. So that is how it is like. That's why we can do the signal based gateway also. Then support of large and dynamic length data types. So it will support all the data types like event 8, we have a event 8, we have say event 32, 16, we can have array, everything we can have. Okay, so it will support large data length. So you can support array of n also. So it can have an array of n means like let's say you have event 8 array. So that array can hold a 1000 bytes, 1024, whatever may be, based on your configuration. So then I'll just dive deep into COM signal values. So we can define the init value. We can define what is the invalid value. We can define some normal value also. So all those values we can define to the configuration. So these just configuration is done in the developer also, or these values we can do the configuration in the this DaVinci configurator also. So Indianness conversion, as I mentioned, we will be having some of the standard primitive data types like Boolean. Then we have a event 8, 16, 32, 8 signed. We can have a array also. So these are the India standardized data types it supports, and it also provides the Indianness conversion also. So we have one parameter COM signal Indianness. That parameter you have to select for the each signal. whether it is a little Indian or big Indian, accordingly that variable or that signal will behave accordingly. So let's say we are using event 16, we have selected little Indian, so it will store lower byte at lower address. Let's say we have a similar variable, other variable event 16 only, and it is as a big Indian, then what will happen, it will store lower byte at a higher address. So like that way. So we have to select because this parameter present for each and every uh, signal actually. Then sign extension, as I mentioned earlier in the first slide only, like if you are getting 10 bit, it will be extended to 16 bit, like that way. Then we have some com signal properties, like how the, because it should not be like it will transmit continuously every time. So we have 93 now. Okay. So it's not like always it will be like that. It should not transmit continuously. So we will be having a transfer properties as well. So what will happen if you consider the triggered as a transfer property, then it will be immediately send and it will repetition. Repetition means like what? Let's say right now you want to send a current voltage of the battery, for example. Then what will happen? It will read it, it will send continuously. It will not check whether it is changed, whether it is modified, nothing. Whatever value it holds in the buffer, it will send at a periodicity. So periodicity is what? Like a 10 millisecond, 20 millisecond, whatever we have configured. It will directly send. That is considered as a trigger. So we will select a signal property as a trigger with a very critical parameters, like let's say battery voltage, battery current, some airbag related status, or safety critical one. So because we never know like what will happen if we delay the transmission, so triggered will be used for a very safety critical parameters or safety critical signals only. Then we have a triggered without repetition, so it will immediately send but no repetition. It means that whenever you want to send, you have to forcefully call com send signal. Then only it will send. It will, yeah, it's like that. Triggered without repetition. So it will send only once, but whenever you are calling that particular API, it will send. In the triggered, what will happen? You just call one time, it will infinitely send. Like that way. Whatever, because it's a trigger. Then we have a triggered on change. Triggered on change means, let's say you have currently we have a 10 value. So it will send once. Now it modified to the 11. Okay, then it will send 11 only, but it will not send 10th again. So it means that whenever it will change the value, it will send that value only. Okay, then we have a triggered on change without repetition. So what will happen? It will only send when the value change, and that is also only once. So 10 to it will become 10 to 11, it will send like that way. And here what will happen? It will send like say 10 value is there, it will now it got to change 11, it will start sending 11 like that way. So that is about the signal property. Okay, so there is a difference between com signal property transfer property and com signal group transfer property. So this is about the com signal property. Okay, now we'll check about the com signal group property. So signal group means it's a group of signals. So signal groups can be 10, 20, signals can be 10, 20, or even more than one is a signal group. Okay, it can be two also. Okay, so triggered means what? It will directly send, as I mentioned earlier. It will not check anything. Group is always sent. Triggered without repetition means what? It will only once it will send. Group always sent, but no repetition. So what will happen is like we have to call that API, then only it will send. The group will send, but it will not send automatically. So in the triggered, it will send automatically. Even if you call once, it will send automatically. In the triggered without repetition, what will happen? Whenever you call the com send group signal, it will try to send. Then trigger on change. Similar. Any of the member. So we have, let's say 20. For example, we have 20. So out of 20 signals, okay, out of 20 signals, let's say one is modified. So then that particular thing will be transmitted like that way. Then we have a trigger on change. So trigger on change means what? It will be like same, like it something is deferred, it will change and it will send. So this is about the any of the member. So in the signal, normal signal, what will happen? It will check for the signal only. But in the signal group, it has a 20. Okay, it has a 20 things. It has a 20 signals, and out of 20 signal, if any of the member differs, it will send. Then we have a triggered on change without repetition. So it will say transmit once only, but the request is like it must change any of the member. Then only it will send. So this is how it will work actually. Then a retry failed transmission request. So retry failed transmission request means what? Whenever that is also a parameter only that we have to set for the certain signal or certain signal group. So whenever we are sending the data and that is failed by any means, okay, maybe something happen or bus is not available or whatever maybe the problem happen, then we can retry the transmission also. So whenever we get a response as a not equal to E, okay, then we can send that particular signal or signal group or I-PDU again, so that it will be sent properly. So generally it will not come this problem, but even if it comes, we have to enable this particular parameter in your configuration, and that time only it will try to send again. So handling of I-PDUs, like same as I mentioned earlier only, like it can be a groups. We can do the start, we can do the stop, and for every PDU we must have either TX all or TX RX all only. Then only it will be like that. Then next will be behavior of the started I-PDUs. So like whenever we do the start, it will be having a COM first timeout. COM first timeout means what? Whenever we do the power run, so you never know like how long it will take to do the transmission of the first transmission. So we will be having certain first timeout delay, like maybe 5,000 millisecond or maybe 10,000 millisecond, because when you start the ECU, it will need at least uh, maybe some 300 to 400 millisecond it will at least take to follow the startup sequence and all those stuff. So what we will do, like it should not show the timeout error. For that we will give the COM first timeout. So whenever power on happens, it will wait for larger time to get the data, so that it will not give the timeout. So for that reason it is a first timeout is considered, and we have a normal timeout like a 50 millisecond or 100 millisecond, like that way. Okay, so similarly in the normal reception, it's like a normal only, like it will receive the data at a 10 millisecond 20 millisecond only. But whenever we have a startup or maybe a power on happen, so it will need certain time, and it will that time will be what we can say at first timeout, COM first timeout. It's like that. So that is about the RX side. Similarly for TX, we will be having the startup behavior. In the startup behavior, what will happen? We never know like how much time it will take. So we will give some first timeout, that is mostly 10 times or 20 times of the real timeout, like a 10 millisecond generally we will be having timeout, or maybe 20 millisecond we will be having timeout. So we will just make it 10 times or 20 times, so that we will not get a timeout error on the power on. So this is about the startup behavior actually, when we do the first start, or maybe whenever we are sending some I-PDU at the first time. So generally it will happen on the power on only. And once power on happens, and whenever we got a first PDU, okay, or first message, then what will happen? It will directly wait and it will uh, check for that delay like a 5000 millisecond or 10,000 millisecond. And once we get the data, after getting the data, it will remove the first timeout, and it will just next time onwards it will start for our normal timeout what is we have configured like a 10 millisecond or 20 millisecond. So after you get the first message, next message it will it is expecting 20 millisecond only, let's say. So it will check whether I'm getting the data at the 20 millisecond or not. If I'm not getting the data at a 20 millisecond, it will raise a timeout error, or maybe a DTC also it will raise. But on power on, it will not raise because we have set as a COM first timeout. So that first timeout you have to always set 10 or 20 times the periodicity. So let's say you have set as a periodicity the 10 millisecond. So you have to set the at least let's say 2000 or 2000 or like that way only. So 10 to 20 times minimum you have to set. So that is about the behavior. And then we have a notification handling callback. As I mentioned earlier, whenever we get a I-PDU, whenever we get a signal from the below layer like a PDR, we must have a notification. So that notification will be like a RT underscore that particular signal name. So that whenever we get a message, whenever we get the data, at that time only we will process the further things. So that unnecessary load will be avoided, and we will not call a certain APIs or certain functions continuously. So to avoid that, we will be have a notification for each signal calls and each signal groups also. So whenever a signal come to the COM layer, at that time only it will try to give a notification, and then further things we will process. So this is just a generalized COMSTACK overview, which all modules it comes with, how things will happen. Like let's say application software components is there. From application it goes to RT, from RT it goes to COM, from COM it goes to PDR, from PDR when the data is more than 8 bytes it goes to bus TP. If data is less than 8 bytes, it directly go to the bus IP. Bus IP means your whatever may be the bus like CAN, Ethernet, LIN, like that way. Then it goes to the bus driver, and then it goes to microcontroller, like that way. This is the flow. But before that, it will first check whether what is the state of our CAN or Ethernet or LIN or FlexRay. It should be a full COM. So the communication manager will check the state management, what is the state. Then also it also communicates with the network manager also, like what is the network state, whether we are getting the data or not. So this NM will be a play a role whenever you want to do the shutdown, whenever you want to do the wake up of the issue. So at that time NM will play a role, and this state manager will play a role whenever you want to check whether it is a full COM or it is no COM, or whether it is a silent COM. So silent COM means only it will receive the data. When it is a full COM, it will receive and transmit the data. Whenever it is a no COM, it will not receive and it will not send data also. So like that way, this is just overview. So that comes to end to this thing, our basics of COMSTACK and all. I hope I have tried to clarify everything. So now I'll just go through these details, like if people are interested, or if any one of you are interested, we will be starting deep sessions from the 10th September. So we have a limit also, like a 10 students per batch, and I have given a link also in our chat, and I'll share you also on the LinkedIn also. So if you want to join this mastery course, you can join this. It's a 25 hours live, and we will be covering all those basic steps like MCAL, then what all configurations we have to do for CAN, then CAN interfaces like CAN layer, what are the configurations like RxPDU, TXPDU, hardware objects handling, all those stuff I'll try to cover. How PDU routing will happen, what all the how TP works, how messages will go, how it will be configured. Each and every parameters I'll try to cover. Communication manager. Then we will be having mappings, NDNS. So I'll give the example also. Then we will be having a transfer protocol, how flow will be like a single frame, first frame, flow control frame, consecutive frames works, how timings will work, how we do the debugging of the multi frames, how NM will work, how shutdown will work, how passive networking, then common integration, how this UDS will work, everything will try to cover in this. Apart from that, we'll give the additional things. We'll give a custom AUTOSAR tool. Obviously, like DaVinci, no one will have a DaVinci tool. It's like a more than 50 lakh cost it has. So we will have a one custom tool. That screenshots also I'll provide you on the LinkedIn. So you will get a feel of configuration. We'll provide a sample ARXMLs. We'll give a 2 mock interviews per person. Okay, and we'll share the interview recordings with each other also. Let's say 10 people means 20 interviews we'll get. We'll be having a doubt solving sessions, around 5 doubt solving sessions. We'll be having some handwritten notes and digital notes, and lifetime access to the video recordings. So these are all things we'll be providing. So we'll be giving all those with a 35,000 cost. But as you all joined by taking out some time, we will be giving a discount of 2,000. So same link I have given in the our chat also, and I'll provide on the LinkedIn also. So if someone are interested, you can fill this registration form, and we can start and we can meet on the 10th September. So thank you all. Thanks for your time. If anyone interested, please go through it. I have shared this link here only. Maybe I'll send here again. And thanks for your time. Okay. I'll also share this recording on the YouTube also. Thank you all. Thanks for your valuable time. Bye.